Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello, welcome students. Once again, today we are going to discuss about physics. We are already done with the introduction to physics, and in that we were talking about science, and how the science topic, science subject is evolved, the systematic analysis of any of the process, right? After that, physics we were talking, and physics is nothing but the study of nature, and which deals with the natural phenomenon we were talking. And I told that we were talking about the time axis in that. So in 15th century, okay, and 16th century, so we are in 2020, right? So in 19th century the actual physics is developed. So we can say the modern physics is developed here, okay. Lot of things is developed, lot of the revolution happened in physics. And here in 15th century Galileo Galilei, in 16th century Sir Isaac Newton, and after that in 19th century most of the physicists were evolved, like Einstein, Max Planck, and other scientists evolved. Okay, that is the thing. So how the physics is developed, and lot of physical the inventions are done and discoveries also done. Okay, so we are going to talk about physical world. Okay, so in the physical world whatever the things are there and all. So basically if I ask you the question means, so in here we are going to talk about some forces. So what is force actually? What is force? Force is nothing but push or pull, right? Isn't it? Or else if I am going to walk on the floor, I would apply some force. If I have to lift this object, I would apply some force, right? A cricketer going to hit the ball in a cricket means a batsman is going to hit the ball mean he has to apply some force. A vehicle is moving, it has to apply some force, right? Any of the object, anywhere you are using, you have to use a force. Now, before in 16th century, people didn't know about that, didn't specified, okay, that is a force. They were telling that yes, there is an external agency is required, okay, there is some external agency is required to move the object, okay. Now there are several forces coming into picture. I will push and pull, that is nothing but the force of my arm, okay, force of my arm, it is nothing but, okay. So I can apply some force, the muscle force we can say. So lifting of the force or different forces. Spring is there, spring, you are going to hang some of the mass, then spring forces, extension, compression, spring force. You will take water in a big container, okay, and put the hand and wave it like this. You will feel some force, right? A resistive force. No, you will wave your hand like this in a air will be there. That air is going to apply some force on you. That is resistive force, viscous force. Okay, now one more experiment is there. In a beaker, if you take some amount of water and small paper you put, okay, before that a needle, slowly keep it on that in such a way that it should not sink. After some times that paper is going to wet, and after that it will sink, but that needle is going to float. You can do this experiment. But why? Because the still water, that is still water having some force, that is called surface tension. I talked about surface tension, I talked about resistive force, that is viscous force, I talked about spring force. These are all different forces are there. But as the discoveries happened, as the invention happened, scientists thought and scientists found based on the experiment that no, there are not multiple forces, there are only few forces, which is nothing but because of that other forces can be derived. I will give you an example. You know, different words we will write down, maybe in English language. Now all are because of 26 alphabets, right? Any word you are going to write down, that is the derived from this alphabets. No. Now I have number 1, 2, 0, 1, 2, 3, 4, 5 till 9. 10 numbers are there, no? Now any number I am going to write down that is derived from this number means this is the fundamental numbers. Okay. So whatever the words are there that is derived from these 26 letters, that is means that these are the fundamental letters, right? Similarly, in physics, I told that spring force is there, viscous force is there, muscle force is there, frictional force, that is when I am walking on the board, walking on the floor, frictional force is there, I am writing on the board because of some force I am going to apply, no, frictional force is there. So these are all forces are there, okay. Those are all nothing but derived from only 4 forces, as all the words are derived from 26 letters. And similarly, here all the forces are derived from only 4 forces, that we will call fundamental forces in nature, that we will call fundamental forces in nature. So which are those? The first one I am going to write down, that is gravitational force, and the second one I am going to write down, that is electromagnetic force. Electromagnetic force. And third one is nothing but weak nuclear force, and fourth one is nothing but strong nuclear force. Now we will discuss about that. So what is this? All other forces are derived from this. That's why we will call it as fundamental forces of nature. Now gravitational force, where you are going to experience gravitational force? Gravitational force, we will study, any object which is thrown upward, which comes back to the earth. Why? Because earth attracts any objects. No, it may be any of the mass, it will attract. Sometimes you may ask that feather is flying, it will go away, it won't attracted by the earth. No? Or sometimes a very light, maybe cotton, very light small piece of cotton, it will fly away. Why? Because the gravitational is not so strong enough to hold on that. That is, air force is so large than that of the gravitational force, that's why it flies. Otherwise gravitational force, okay, so that it will come. So gravitational force, where and all we are going to get gravitational force? We are going to get the gravitational force only because of mass. If you have a mass means you have a gravitational force. It is nothing but because of gravitational force is nothing but by virtue of mass. Okay, you are going to get. If any object is having mass, gravitational force is there. Now it is having mass. It is having mass. There is a gravitational force between them. Okay, a planet is having mass, sun is having mass. There is a gravitational force between that. Earth is having some mass, this object is having mass. There is a gravitational force between them. The gravitational force arises because of by virtue of mass. Okay, if any object is having mass, there is a gravitational force. Okay, now what is the nature of the gravitational force? It is always attracts. Whatever it is always attract. attractive in nature. Okay, gravitational force is always attractive in nature. Now, gravitational force is only in Earth, we are going to find out, or somewhere in space I am going to get. There is a gravitational force. Everywhere is there. Everywhere is there. Okay. Now you may ask the question that now outside if you go means in the space, sometimes what happens, you won't feel gravitational force at some point, because the another force, the planet, the force by the another force, another planet and the Earth becomes equal sometimes, or else you are outside the gravity means you are not going to experience a gravitational force. Where you are going to experience a gravitational force? Gravitational force you are going to experience only when you are in a range. So Earth can attract, there is some range is there only it can attract. Outside that if you go means you are not going to experience any gravitational force. So gravitational force is universal. Everywhere you can see the gravitational force. Gravitational force is universal. Okay, and that is what about gravitational force is. So this is what the important terms they are going to ask. What is the gravitational force? Why gravitational force arises? Gravitational force arises because of the mass of the object. Any object which is having mass, which is they are going to have gravitational force. Okay, one thing is that. Then this is always attractive in nature. This is always attractive in nature, and after that it is a universal force. Everywhere in the universe if you go, you are going to experience the gravitational force. You are going to experience, you are going to see the gravitational force. Next we are going to find there is a next fundamental force, that is nothing but electromagnetic force. That is nothing but electromagnetic force. Electromagnetic force. Electron, magnet, force, no? Yes, this is came because of the charge only. In atom, if you see, okay, electrons are there, no? We will say which is having a charge, that is minus charge. There are two types of charges. One is positive, another one is negative. Okay. So what happens now? As I said, people were, scientists were doing the experiments. Now if you do one experiment, I'll tell you, a wire is there, connect a battery in this way, positive and negative. Okay, compass needle is there, right? Connect a cell, connect a small cell, that is sufficient. Okay, so wire, connect a small cell in such a way that compass will be there, no? Compass needle you keep here. Okay, north and south. Now we have not switched on it. Okay, if we switch on it means what happens? Whatever the charges are there in this, they will flow, and those charges will create its own magnetic field. Own magnetic field means I didn't keep magnetic compass now. Its own magnetic field is there, means it behaves as if like a magnet. Now one more magnet, that is nothing but compass needle if I bring means, since it is very small magnetic force, it can deflect this magnetic needle. Compass needle if you have means you can do this experiment. Okay, so means that charges are moving which will produce as a magnetic force. Which will produce as a magnetic force. If charges are moving, they will produce a magnetic force. If magnet is also can deflect the charges. Okay, magnet is also deflect the charges. So scientists understood from the experiment that yes, magnetic force and charging force. Okay, magnetic force and electric force are always aligned along with each other. So name is given electromagnetic force, and that is because of the motion of the charges. It is because of the, by virtue of motion of charges. Okay, if charges are moving, then only. If charges is stationary means at rest. Okay, there is no force, there is no electromagnetic force. If they are moving, yes. Then whether it is attractive, whether it is repulsive, see, it is both. There is attractive also sometimes and repulsive also. Two kinds, okay. There are two kinds of electromagnetic force, okay. That is nothing but sometimes it is attractive also, sometimes it is repulsive also, electromagnetic force. Why? Because there is two types of charges, no. Positive charge is there, okay. Another one is negative charge is there. That's why there are two kinds of forces we can say. Then what is the range of the range? Till how long you can experience electromagnetic force? See, I said if you go outside from the earth, you are going to experience some force, no? You are going to experience force. That is the gravitational force. Till how long you have to go, so that you have to move away from the gravitational pull? That is long range, very long. But here also certain range is there based on the capacity of the magnet and charge, okay. Here also almost to long range force itself we are going to call. So here also, that is the gravitational force is also long range force. But if you consider this range, the range of the electromagnetic force less than that of the range of the gravitational force. Gravitational force is having large range. You can't have such range here in electromagnetic force. But considering these forces, little more range. That's why we are going to write a long range force. So what is that electromagnetic force? Electromagnetic force is because of the moving charges, okay, and the combination of electric and magnetic force. Okay. Now weak nuclear force. One more force. We were talking about fundamental forces in nature. And this is nothing but weak nuclear force. You won't get everywhere this nuclear force. Okay, this one, weak nuclear force. Only in few reactions we are going to get. We will call it as nuclear reactions. Okay, found during nuclear reactions. Okay, so what are those? See, atom is there, electrons are there outside, inside the atom protons are there, neutrons are there. We are going to talk about electromagnetic force. After that, next one is weak nuclear force. Okay, next one is weak nuclear force. When it arises, we were talking about that, like atom is there. In the atom we find at the nucleus is there, protons are there. Okay, so what happens when it is bombarded with the neutron? Here the neutron is converted into one electron and other positron. Okay, electron comes out. That time a weak interaction we are going to get. Okay, so very rare, in only nuclear reactions we are going to get weak nuclear force. That is a weak nuclear interaction. Okay, we will get a particle, that is neutrino and antineutrino, that will be having a weak nuclear interaction, and we are not going to get many of the in surrounding as such. Only in the nuclear reactions we can get this weak nuclear force after electromagnetic force. Then what will be the strength? Strength will be stronger than that of the electromagnetic force. Strength will be stronger than that of the gravitational force, but it is less than that of the strong nuclear force. Here it is the third force, okay, that is weak nuclear force. Next, strong nuclear force. Okay, so where we are going to get the strong nuclear force? We know already, again I am going to tell, that is nothing but an atom. In nucleus we have proton, neutrons. No? Is there only one proton in all the atoms? No. Number of protons are going to increase, right? Okay. But I have told, we have discussed, same charges, like charges are going to repel. Now proton is there which is having positive charge, proton is there in positive charge, they has to repel. But what happens in the nucleus, the number of protons bound together, means there is a repulsive force between the proton and proton, but still nuclear force the strong nuclear force makes that proton to bound together. That is what? That is a strong nuclear force. Okay, that is what? That is a strong nuclear force. This force arises between the elementary particle or proton in that way. Okay, in the elementary particle, this force is going to, we are going to get. So it is a very strong force. It is a very strong force. If you compare to all other forces, the strength is very strong. But what is the range of the force, nuclear force? Till how long it will be strong? See, the gravitational force is there. Gravitational force is enough capable to pull you down from certain height. No, though you move to certain height, gravitational force is enough capable to pull you down. You throw this object, gravitational force is enough capable to pull you down, right? But what about the nuclear force? Nuclear force is not like that. Along, with respect to strength we are talking about. Nuclear force is what? Nuclear force is a very strong force, but it is having very small range, very small range. In our previous videos we have talked about the size of the nucleus, 10 to the power minus 14 or minus 15 at the rate. Minus 15 means how much? 0.00014 or 13 zeros after that? No. 10 to the power minus 14 or minus 15 means, in that order you will get. Okay, always very small. So in that range, the range is very small. Okay, very small range comparing to these forces. The range of the nuclear force is very small, very less. So this is about nuclear force and all, weak nuclear force. Now I was talking about, we were discussing about surface tension, we were discussing about viscous force, we were discussing about spring force, we were discussing about weight. No, weight we are going to calculate. No, in a machine we will stand and we will find out the weight. These are all different forces are there. We are not going to talk about that in this. They are not comes under these four fundamental forces. Why? Why? Because earlier we have talked, earlier we have discussed. What is that? We have discussed that. I gave an example that all words in the English alphabet, that is nothing but because of fundamental letters, 26 letters. No, so in same way, this spring force, viscous force, surface tension force, these are all because of the fundamental forces of this. All other forces I can say by the combination of these forces. All other forces I can say by the combination of this force. Then spring force. Spring force is a combination of electromagnetic force because of the charge, because of the molecular arrangement. Okay, that spring force is there. Okay, then I can say surface tension, then I can say viscous force because of the molecular arrangement. Because of the molecular arrangement we can explain using electromagnetic force. Now you will stand in a weighing machine, your weight comes. No, that is nothing but not mass you are calculating. Mass is nothing but amount of substance. Weight you are going to get maybe 60 kg weight, 60 Newton or 70 Newton. Okay, like that if you calculate means any number that is based on your mass into acceleration due to gravity. Okay, you are getting weight. That is because of the gravitational force. Okay, that is because of the gravitational force. Again I am going to tell this weak nuclear force we are going to get in the nuclear reactions, and after that strong nuclear force always will be available in the nucleus. Okay, now what is the questions or how the exam pattern they are going to ask? Only these points they are going to ask. Okay, about the range, about the strength. Okay, and I have written in an order. It is a small range, sorry, it is a long range and small strength. It is a small range and long, heavy strength, very strong. So based on the strength they ask you to align. Based on the strength, increasing means strength, less strength, little more and very more strength. Range, decreasing order, that is very large range, little less range, very less range, very less range. That is the range of the gravitational force, like that we can say. Okay, but we can't say the range exactly, but comparative, all are comparative. Okay, it is comparing, the range is very large comparing to strong nuclear force. Okay, and the range here you can make out long range, not as such of this, but little range, more than this, not 10 to the minus 10 meters, 5 meters, like that also you can have the electromagnetic force. Okay, this is about the physical world we were talking about. Okay, that is nothing but 4 fundamental forces in nature that we are going to study in the physical world. This is what we are going to conclude the introduction as well as physical world about the physics. We are going to conclude here. Okay, the thing I can repeat, I can say that we have talked about science, the systematic analysis. Next we talk about physics and the branches, and after that what is physics we talked, and after that we were talking about the physical world. In that we were talking about the fundamental forces. Okay, for the exams 2 to 3 marks questions will come based on the range, all those things. Okay, that is what about physical world.
Don't forget to like our video and subscribe our YouTube channel for all the updates.